Roughly 70% of students couldn't get part C of this question. That means that the majority of people answering the whole question lost 4 marks out of 7. The good news is that part C is actually surprisingly easy. After we use the previous sections as building blocks and also deploy our trigonometry knowledge, as you'll see in a moment. We start off by being given 3 position vectors and are told that a combination of these 3 vectors plus another vector D creates a parallelogram ABCD. Next, as you can see, AB equals DC. Because the opposite sides of a parallelogram are parallel, which means that the opposite sides will be the same from a vector perspective. Knowing this, we can find AB by saying AB is equal to OB minus OA, which equals 2i, 2j, and negative 1k. Remember now that we obviously don't know what OD is, so we can let that equal x, y, z. More specifically, xi, yi, zi. It's just the point. Armed with this knowledge, we can therefore say that DC is equal to OC minus OD, which equals 3 minus x, negative 2 minus y, and negative 4 minus z. Now, remember what we said earlier. AB is equal to DC. Therefore, 3 minus x equals 2. Negative 2 minus y equals 2 as well. And lastly, negative 4 minus z equals negative 1. After this, simply solve the equation for x, y, and z, and you'll get OD is equal to 1, negative 4, and negative 3. Now, we are told that the angle between BA and BC is theta, and it wants us to find the exact value of cos theta. What will be helpful here is to define what BA is and what BC is. BA is equal to OA minus OB, which equals negative 2, negative 2, and 1. BC is equal to OC minus OB, which equals a negative 1, negative 5, and negative 6. Plugging this into the dot product formula, A dot B is equal to the magnitude of A, magnitude of B, cos theta, we will get 2 plus 10 minus 6 is equal to root 9 times root 62 cos theta, which we can finally rearrange to get an exact answer of 2 over root 62. Now, as alluded to in the intro, this part is by far the most difficult, so listen closely. It wants us to find the area of ABCD in the form P root Q. But to do this, we have to figure out what the area of ABCD should even be. The trick here is to remember the area rule that you would have been taught during GCSE. That is, you can calculate the area of any triangle by using the equation half times A times B times sine C. So then, remember that a parallelogram is nothing but 2 triangles put together, which means we can apply this for each triangle, which means our equation changes from half times BA times BC sine theta to 2 times half times BA times BC sine theta, which is BA times BC times sine theta. The only thing is now we don't have sine theta, but we do have cos theta from part B. So the question is, how are these related such that we can find sine theta? If you remember, sine squared theta plus cos squared theta is equal to 1. So therefore sine squared theta plus 4 over 62 equals 1, which means we can get sine theta as root 58 over 62. We know the magnitude of BA. We know the magnitude of BC. And we know the magnitude of sine theta. So therefore, we have 3 root 62 times root 58 over root 62, which gives us 3 root 58.